Hi there and welcome to this video, which is going to run through a historical timeline of astrophysics. It's going to look at the pioneers who actually paved the way to give us an understanding of how the cosmos really looks. It also will highlight some of the technologies that we utilized to gather the data which allowed them to draw their conclusions. So basically we can go back to the beginning of time when man looked up to the heavens and asked the question, what is out there? There are many different views going back to Babylon and China. This gives us a snippet of views of how people gave stories around the cosmos. This was taken from The Lion King, run by Disney.
Timon!
Yeah?
Ever wonder what those sparkly dots are up there?
Pumba. I don't wonder. I know.
Oh, what are they?
They're fireflies. Fireflies that got stuck up in that big bluish black thing.
Oh, gee. I always thought they were balls of gas burning billions of miles away.
Pumba, with you, everything's gas.
Simba, what do you think?
Well, I don't know.
Oh, come on,
well,
give
Simba, come on.
We
Come
told
on.
ours.
Give.
Please.
Well,
Give.
somebody once told me that the great kings of the past are up there, watching over us.
Really?
You mean a bunch of royal dead guys are watching us?
Although this is Disney's version, it's not far from the truth as to how people try to explain the heavens. They put stories together which entertained but also had an element of truth. One of the first recognized pioneers was put forward by Aristotle. He lived in northern Greece in a place called Stagira. He put forward the idea given by Pythagoras that the shape of the earth and moon was a sphere, and he stated the sphere is a perfect solid and the heavens are a region of perfection. The earth's component pieces falling naturally towards the earth would press into a round form. In an eclipse of the moon, the earth's shadow is always circular. A flat disk would cast an oval shape, hence the idea of the sphere. Even in short travels northwards, the pole star is always higher in the sky. So Aristotle tried to put forward his idea of this spherical object, that we weren't flat. Now, if you think about that and the idea of early sailors that the earth was flat and if you sailed to the end of the earth, you would fall off, this isn't too far from the truth. Quite an extreme idea to put forward, considering the time at which Aristotle was around. The next pioneer that we look at is Aristarchus of Samoa, again an ancient Greek astronomer and a mathematician who put forward the first known model of a sun-centered universe, and that the stars were bodies like the sun. These went against the theories of Aristotle, who stated an incorrect earth-centered model. But you'd be amazed how Aristotle's idea was accepted by early pioneers, and it was nearly 18 centuries before Aristarchus's idea was actually taken on board and looked into in a lot more detail. Another person who was responsible for our knowledge of the Earth was Eratosthenes. Again, he was a Greek from Cyrene who calculated the circumference of the Earth applying mathematical measurements. He used shadows and geometry to extrapolate distances and thus calculated the Earth's circumference. Hipparchus then came on in 190 to 120 BC. He was born in Nicaea, Bithynia, Turkey, and basically is the founder of modern trigonometry. Now, basically, these laws of trigonometry allow us to actually utilize and measure distances and determine distances that allows us to look at angles and how far away certain objects are. So he's classified as a pioneer with respect to astrophysics because he gave us the tools which allowed it to measure the heavens. Next person we're going to look at is Ptolemy, 90 AD. Again, he was an Egyptian astronomer who put forward again the idea of an Earth-centered universe with the stars forming the backdrop. Now, this is going back to Aristotle's idea. His hand-drawn model is shown here. Now you can see here that we've got the Earth in the center, and it goes with a backdrop of the stars. Then we've got the planets, which are moving outwards. The bottom right-hand corner shows us a little bit more simplified, the version that we see in the hand-drawn version. The idea being that as the Earth spins, as the Earth stays stationary, the stars then move around us. Hence, that's why we see the stars at different periods of the year and different constellations. The planets then move within these areas. So this was actually accepted for a long, long time. Basically, why else would the Earth be anywhere else? Why should it not be the center of the universe? And remember that you've got to take into account that a lot of these early pioneers followed the gods, and the gods basically were looking down on Earth. They created Earth, they created man, and as a result, they put the gods would surely put the Earth at the center because that's one of their creations. So although we seem to understand that we go around the sun, you've got to take your mind back as to what it would be like if we had no idea. So this is not as far-fetched as you may seem. The next person we're going to look at is Copernicus. Now he was basically a clerk in Poland, and he put forward the idea, the model of the universe from Aristarchus, that it was a sun-centered solar system. However, his model was incredibly difficult to decipher and consisted of many different circles. And again, we can see a model in the top right-hand corner, but the simplified version is a lot more easy to understand. There you can see we've got a sun center, and then the planets move out, and then we've got motionless stars in the distance, with the idea that the Earth and all the planets actually move around the stars. Now, this is a lot more similar to what we understand today, but at the time of Copernicus, this is like a major thing to state, because remember, we're living in an age at that time where religion was very, very important, and basically everybody believed that God put us in one position which allowed the planets to revolve around us. So next we look at Tycho Brahe. Now Tycho Brahe was a very eccentric scientist, and basically he was an astronomer. He went to Prague and he worked for the emperor in Prague as his astrologer. Now, don't get confused between astrology and astronomy. Astrology is basically looking at how the planets align themselves to govern the future, whereas astronomy is more of a process of looking at the heavens and trying to decipher what's going on. So anyway, Tycho Brahe went to Prague, and he worked for the emperor as his astrologer, and it gave him the opportunity to have money which allowed him to observe the stars. Although a little eccentric, he was an excellent data collector. He mapped the position of the stars to great detail, and throughout the night using his quadrant, which you can see here. Now what he did was the arm that you can see, which is pointing around about 45 degrees, was pointing towards the various stars, and then he used the arc to measure the distances and the angles that those stars happen to be throughout the night. Now he had extensive data which allowed us to then utilize that data to come up with a conclusion. Now it was later on, or towards the latter part of his life, that Johannes Kepler, who was born in Germany and a mathematician, came and worked for Brahe. Now it wasn't so long after Brahe died that at one of his famous parties, apparently the story goes that he got drunk, and he had a 3-day party, and he got drunk and decided not to go to the toilet, and his actual bladder exploded, although whether that's true or not remains to be seen. But at this time, Kepler was one of his assistants, and again the story goes that Brahe really didn't like much of Kepler, and kept him away from a lot of his data. But when he died, Kepler got hold of this data, and he spent the next few years trying to make sense of the Mars loop. Now, the Mars loop can be seen here, and what it was the fact that through Brahe's data, Mars seemed to take a backward journey away from us and then started to accelerate. So you can see that this loop has been generated. Now this has perplexed the Greeks for a long time up to this point. They observed this but couldn't put a reason behind it. Now the Greeks really loved circles. They tried to put everything into a circular model. Now as a result, because of their early history and what have you, everybody accepted that there must have been some circular motion. So there's Kepler looking at Brahe's data, and he accepted that Brahe's data must be correct. Now again, the story goes that he decided after about 5 years or so that he couldn't make Mars Loop, or couldn't get Mars Loop to be explained. And so what he did, he threw out all his conclusions, went back to the basics, and instead of using a circular model, he started dealing with other shapes. And from this, he found a shape that actually made sense, and that was the ellipse. And from this, he produced three main laws. The most profound of these laws was the ellipse, but he also looked at area and period, and the idea that as the planets move around the sun in an ellipse, they change their speed. But the time period going between various areas was the same as they covered a certain area. So there was a link between area and time period and speed. So now we've got this idea that has explained Mars Loop. Mars Loop, as I say, was this observation that the Greeks had picked up way before Christ, but couldn't explain it. They wanted to work with circles, but Kepler said now that we were having planetary orbits, which basically went into ellipses. Now, at the same time, in Italy, Galileo Galilei was developing his first telescope. He was an astronomer, basically wasn't really going anywhere, and he heard this idea of a Dutch spyglass. A person came to Venice and was talking about the spyglass, and he thought this was a really good idea. And what he did, he went to Marino and got some glass. He got an organ pipe, and he made his first telescope. And here's a picture of his telescope here. Now, the idea behind the telescope was it was going to be a really good tool for magnifying objects. Now, here's our first idea of technology. Well, probably our second idea of technology if we look at Tycho Brahe's quadrant. But this telescope was used to magnify objects which are far away. Now, this was great for Venice because it's on the sea and very big trading area. So as a result, it was open for attack by pirates. So using the telescope, Galileo was able to give a couple of hours of time when new ships or invading ships could come in so they could man their defenses. But then Galileo started looking up to the heavens, and he started using his telescope to gather data of the heavens and what was going on up there. And from this, he was able to get some detailed pictures of the moon. And here's an idea of what he produced. These are his drawings through his telescope of the moon, and you can see all the craters and beautiful pictures that were created. Now, he wrote his first book that was a huge success and virtually made him famous. But then after writing his second book, he pushed the idea of a sun-centered universe. Now, this was all going on during the time in history of the Reformation. This went against the views of the church and lost the church some form of power. So he was found guilty of sedition and put under house arrest. And it wasn't until well after his death that his theory was realized of this sun-centered universe, which he pushed for. However, for his groundwork in science investigation and his idea of gathering data and then drawing conclusions, he's now named the father of science. So our next pioneer is Christian Huygens. Now, he's a Dutch physicist, mathematician, and astronomer, and he was renowned for using telescopic evidence of the rings of Saturn, and discovered one of its moons, which is Titan, which you can see here. Our next scientist is Ole Rommel. Now, he was a Danish astronomer who was able to determine the speed of light, which is 3 times 10 to the 8 meters per second. He compared the duration of Io's orbits as Earth moved towards Jupiter and then moved away over a 6-month period. By doing a comparison between the changes in speed due to these eclipses, which is apparently around about 11.2 minutes, he was able to work out not only the distance that we were moving, and he related that distance to the speed at which light had to travel at any one point. So as a result, he came up with this figure for the speed of light. Now, this is within 20% of what it actually is today, which is pretty damn good considering the time period that Rommel was dealing with. Now, currently the sun-centered model had been accepted. We know that Kepler's laws stated that planetary movement was in an ellipse, and that the speed changed as the planets approached the sun. Galileo produced an instrument that helped astronomers observe the planets and stars. However, no one could explain what held the planets in their motion around the sun. And it was down to Isaac Newton, an English mathematician and physicist, who proposed the theory of gravity, being this magical force that held the planets in their orbits. Isaac Newton is famous for promoting 3 laws of motion, as well as proposing theories of light and calculus, which he published in his famous book, The Principia. This revolutionized our understanding of planetary movement. More of Newton will be studied throughout this iTunes U post. Much later on, our next big astronomer is Edwin Hubble. He was an American who proposed the expansion of the universe from a specific point. His theories then led to evidence to back up the theory of the beginning of the universe, the Big Bang. For his huge contribution to astronomy, his name was given to the Hubble telescope. We can see the Hubble telescope here, and this sits outside our atmosphere and takes incredibly clear pictures of our current cosmos, as you can see surrounding this image here. Lots of people think he invented the Hubble telescope, but unfortunately not. Now the NASA have put out another big telescope, the J Webb telescope, which basically can look into space a lot deeper. So finally, our next major astronomer obviously is Stephen Hawking. He's an English theoretical physicist who has proposed theories about black holes in his book and promoted further evidence for the idea of the Big Bang. He's also worked on continuation of Einstein's theory of relativity and quantum mechanics. And so basically our understanding of the cosmos and the universe keeps going on. New ideas will hopefully be formulated as our technology increases. So that just gives you an overview, a very brief overview of some of the scientists who have led to our understanding of the universe. I hope you found that interesting, and we'll be delving a little deeper into some of these scientists later on in this course. Well, thank you for watching, and I look forward to you joining me again. Bye for now.